In this video, we're going to discuss how do we perform linear regression using our calculator. Okay, so as we discussed in class, the correlation coefficient, which has a symbol R, it's the sample correlation coefficient, is a measure of the linear correlation between ordered pairs. Okay, so as we discussed in class, imagine, get a little space here. Imagine a scatter plot. And what's a scatter plot? It's simply, all right, you have a horizontal axis, you got your vertical axis, and you have a bunch of ordered pairs plotted. Okay. Say we had something like that. And then let's compare that graph to one that looks like this. Okay, so the correlation is the measure of the strength of the linear relationship between your ordered pairs, your data values. And so the closer your ordered pairs, your data values, the closer they are to being a straight line, the stronger we say the linear correlation is. So this correlation coefficient is a measure of how strong that relationship, that linear relationship is between your data values. All right. So as we look at the two graphs that I have plotted here, let's call this left one A, let's call the right one B. We see that A has a stronger correlation. Why is that? Because the data values are less spread out, or they're closer to being in a straight line compared to the values in B. Now, overall, both of these graphs do exhibit what we call positive linear correlation. However, graph A has a stronger positive correlation compared to graph B, which has a weaker linear correlation there, a weaker positive linear correlation. So R is a numerical value that measures that correlation. R will go between -1 and 1. The closer your R is to -1, the stronger the negative linear correlation is. And the closer your R value is to a +1, the stronger the positive linear correlation is. Okay. Well, to calculate R, we have a nasty looking formula. And in fact, this may not be a surprise. This formula is actually based off the standard deviations of your data values. But anyways, R has a complex formula, but allow me to show you a way of calculating R using your TI 83 or 84. All right, so the first thing that you must do in order to calculate your R is that you must enable your diagnostics. And this is the way that you do this. Let me pull up my calculator. To enable your diagnostics, you're going to hit second 0. That is going to bring up your catalog. In this catalog, there's an option for diagnostic on. It turns on your diagnostics. And so that's what we want to get to. So either you can scroll all the way down till you get to the D's. That's a lot of scrolling. Or, I don't know if you guys can see it, but my X to the -1 button, above it, you can see like a green D. I don't know if it'll show up. But if I click that, that'll take me straight down to the D's. And now I can find, eventually, diagnostic on. I select that by hitting enter, then I hit enter one more time to actually enable the diagnostics. All right, here's the deal with turning on your diagnostics. You do not have to do this every time you want to calculate a linear regression. You only have to do this really one time unless your calculator is reset. Okay, if you reset the memory on your calculator, then you'll have to do this again. So if you don't take out the batteries, change the batteries, anything like that, or reset your memory, you're good to go. So our diagnostics are enabled. So the question is, how do we actually calculate the correlation? So let's jump straight into an example. For here, we have two data sets. We have height in inches of individuals, 5 individuals, and then we have their corresponding weight. We want to determine the correlation between height and weight. Well, to calculate that, we're going to, first of all, take the height. We're going to plug that into our L1, our first list, and we're going to take the weight data set and plug that into L2. These are ordered pairs, meaning they are paired data. So you have to make sure that the 60, the first entry of L1 is 60, and the first entry of L2 is the corresponding 115, the weight for that person. So here we go. Stat edit. I'm going to clear out all this unnecessary junk. And I'm going to put my X variable, in this case the height, or excuse me, the height, I'm gonna put that into my L1, which was 60, 63, and so on. 69 and 72. All right, L2 are the weights. Make sure you put them in the correct order. 140, 152, and 165. Okay. Now, how do we calculate the correlation? This is what we do. Hit your stat button. You're going to go to the calc menu, and you're going to select number 4, len reg ax plus b. That means a linear regression of the form ax plus b. We hit enter. And here we go. Our X list will be, where do we have our X variable? Well, it's in L1. Our Y list is, where do you have your Y variable? It should be L2. Your frequency list should be cleared out. There shouldn't be anything for a frequency list. And this store reg EQ means store regression equation. We're going to leave that empty. Okay. Go down to calculate. And a bunch of values pop up. If your calculator is not maybe updated like mine is, when you click len reg ax plus b, it took you back to the home screen. What you want to do in that case is you want to type in L1, comma L2, and to ensure that the calculator is going to grab the right data sets. Okay, so our correlation coefficient is the R, not the R squared, but the R. And our R, as you can see, is a positive point, I'll go 4 decimal places, a positive 0.9999. So R equals a positive point quadruple 9. Remember, R can be either positive or negative. So make sure you pay close attention to whether or not the R is positive or negative. And what this means, well, R is super, super close to a positive 1. So that means we have really, really strong positive linear correlation. Okay. What does that mean? Well, we'll get into what's known as the best line, the best fit line, or the linear regression. But just right now, what that means is that if I were, so remember your X variable is the height, and the Y variable was the person's weight. Whenever you have a strong linear correlation, you're saying that the data values follow in a pattern where they're going to be close to a straight line, and that positive means that you have a positive slope on that line. So what that means is that, and this makes sense, right? As a person's X value, as a person's height increases, generally so will their weight. That's what the data set is telling us. If you have a positive linear correlation, it means as your X values increase, so do your Y. If you have a negative linear correlation, that means the opposite. As your X's increase, now you're going to have a smaller Y value. So that's how you get your correlation coefficient. Well, the next thing that you want to do is you want to be able to calculate something that's called the line of best fit. And the line of best fit is a line, obviously, that best models your data. What I mean by that is if I go back to the scatter plots that I drew earlier, where are you guys at? And if I were to draw a line that kind of best followed that data set, go to graph A here. The line would be something like that. I'm a little off a little bit, but that would be a best fit line. It's the line that best, let's draw a better one. What it is a line that minimizes the error between your data values and that line. So there's only one best fit line, and it's the red one that I drew there. Well, here's the deal. So we want to be able to calculate that best fit line. Well, the fantastic news is that there's no extra work. The calculator actually already does this calculation for us. Remember how we calculated R? This is our same data set. Y is equal to AX plus B. Okay? So what that means, our best fit line will be of the form Y equals AX plus B. Okay? That's what we just selected. Now, what you'll see sometimes is you'll see people put a hat on top of that Y. And what that means is that we can actually use this best fit line to predict new values that are not in the original data set. So it means if you want to predict a new Y, it's a Y hat, you could plug in X5. Anyways, the calculator tells us what the slope and what the Y-intercept is of our best fit line. And it does it in the same screen as the R. So what we can see from there is that our best fit line will have a slope, an A of 4.1667. Let's go 4 decimal places. And the B is a negative 135.2. So let's write that down. So just grabbing that information, our best fit line is the equation. Well, A was a 4.1667 times X plus whatever your B is, where our B happens to be a negative 135.2. So I'm going to do a minus 135.2. This is what we refer to as your best fit line. Okay. In the next video, I'm going to show you how do we use that best fit line to make predictions, and how do we make sure that that prediction is what we call reliable and reasonable. So in the next video, I'll show you how to use the best fit line. See you there.